spectrum, we had a number of models for different types of content moderation. So insults, hate speech, spam, really a pretty wide gamut. And then at Nurdle, we're working a lot with generative models. So using RAG and fine tuning, as they're kind of appropriate for the type of data that we're creating. We're working a lot with ChatGPT and Llama and then other models as well.
One of the first things we did was using BERT to explain recommendations to assistant users. So we recommend a movie and try to explain why it's a good movie for you, right? And then I worked on things like on search doing journey prediction. So if you search for, let's say, this is my favorite one. If you search today for how to break up with my boyfriend, we try to predict that in a week from now you'll be searching for how do I get back with my boyfriend. That actually was from one of our data predictions.
We are using LLMs to essentially enable qualitative data analysis. So we can essentially take a definition of something you might care about, is this question about programming or something like that, and then we can bootstrap a classifier that can kind of determine whether or not the question is or is not about programming, just by sort of fine-tuning a quick little classifier on it using LLM generated labels. So lots of cool stuff like that that's been enabled by the generative models that have come out lately.
When you've got a custom problem in mind, right, is you can always take some data, maybe your PM is giving you a lot of data, and then you manage to train a model, or you fine-tune a few shot, and you find a model that has just a little bit of extra performance, right, compared to your baseline, right, your pre-trained model or whatever, and then that's just the first step. And the question is the costs of actually deciding to launch that model involve things like the deployment costs, maintenance costs. It's a whole extra set of configuration files or things that your engineers, your SREs have to continuously maintain and monitor, right? Because models get out of date. Something like COVID happens, and you've got to have somebody tracking all the metrics for all the different models out there. So it's just extra overhead each time. So you've got to make this decision, and I'm not really aware of any simple, framework of assessing the costs against the benefits. You just have to figure it out each time.
One of them was performance, of course, precision and accuracy. And then we also had pretty stringent requirements on timeliness, because we were processing data in real time. So sub 10 milliseconds or so was what Bryce demanded. So getting the models down, getting larger models down to a size that would run, size format, etc.
A lot of the question when deciding whether or not to deploy a fine-tuned information extraction model was just is it good enough? So if you put the results into a product and show it to people, are they going to be that's not true, And so a lot of that is just kind of getting the quantitative sort of metrics right, how is the F1 score, how's the precision, how's the recall, and then you just get that for each class. With LLMs, you kind of mostly have to do the eyeball test, or I guess generative LLMs, because there's not really any good ways of quantitatively evaluating them yet, and so it's just many.
I think it's also useful to consider how you might think of problems like having evaluation sets that might be out of domain, right? Because this is a very frequent problem with machine learning models, particularly bigger ones, right? They get really, really good at doing the task on the exact data distribution that it receives. So if your data set that you're getting from production consists of say 75% medical queries and 5%, dating advice and other stuff, then it gets really good at reaching high accuracy on that. But when that percentage shifts, right, when life changes, the season changes, right, performance can drop much faster than many people, someone who's not used to these things would expect, right, because it goes out of distribution, as we call it. So having test sets that cover different mixes of data, right, that you can evaluate against, I think is a really important thing that maybe people don't do.
Something like GPT-4, which is an extremely performant model, we kind of thought it probably can't create user-generated content style data or social media style data easily, but obviously you just always run the experiment, you don't make any assumptions. So if there was a way to quantify the fellow kids metric, that would be awesome. But for now, that's a good eyeball metric. So yeah, I think as to what Charlene was saying earlier, like for generative models, the evaluation becomes really challenging. And at Spectrum, I would say one of our main challenges was that we didn't have we had a huge class imbalance. Like, most of the people on these various apps are saying nice things to each other. They're, talking about games, other things. So it's a pretty small proportion that's just on there to be a troll or edgelord or something. So you're not necessarily going to source a lot of truths. And when you move beyond English, that is, even more so true. So we might try sampling for truths, but in lower resource languages where we're not performing as well, we're not able to find as many. So this is kind of one of the reasons that Nurdle kind of spun out of Spectrum, is that it is actually like easier to generate these synthetic examples rather than trying to source them, or at least like it's a faster and cheaper way to be able to evaluate correctly, which is kind of the first step to improving performance.
I also did a project where I was evaluating how our named entity recognition model was doing on different like news sources from different countries, so like non-English speaking countries. And the NER model I discovered was actually doing much worse on certain countries because they just sort of like use English differently relative to like how the English speaking publications like the New York Times or whatever were using it. And like our model was trained on, all of this very clean like CNN and stuff sort of data, and not any of that. And so that was one very like obvious point of improvement. And one kind of dead giveaway that was happening was like on like the Chinese data set, for example, I noticed that like the performance for organizations was really, really low. It was like 0.2 F1 or something. And I was like, what's going on here? And I noticed that like in that evaluation data set, it was just failing on the exact same entity over and over again, like a particular organization name. And I was like, interesting. So it's also worth looking at your evaluation data to make sure that it's like, diverse and accurately representing kind of, like you were saying, like the data that is actually going to run out in production, because it turns out Primer did actually have a lot of non-English news sources or non-English speaking countries writing in English that tended to be very different distribution-wise. A lot of what I've been doing, admittedly, is just looking at the data. You would be actually amazed how far that gets you. Because especially in just traditional NLP where you're doing an information extraction task, a lot of people are like, oh, I can use a quantitative metric, so I'm just going to look at the F1 score and the precision recall or whatever. But like, it actually helps a lot from a qualitative perspective to look at the actual results and just make it very, very easy to kind of see like where exactly is my model failing, like which examples is it failing on, because that literally points you directly to the kinds of data that you then need to collect to fix the model. And so I think just looking at the data is like very underrated as a strategy. It doesn't like super scale, obviously, but like at the beginning, as you're trying to kind of get your thing off the ground and make sure that it works very well.
One of the things that we had to do at Spectrum was see how the model is performing on more recent data, as well as like a gold standard data set to see that, we're not seeing unexpected drops. And also testing on more recent data because language and slang changes so rapidly that things can change pretty quickly, similar to what Deepak mentioned about COVID becoming, a new term. Language is lots of fun. We basically had a number of tests that we would run before we would put any updates out.
Like Charlene was talking about, you have these metrics from a long time ago, like blur and so on, you might have heard of. They're pretty bad. It's really hard to use them reliably as a way to know if model version X is better than model version X minus 1. So we ended up at the beginning of BARD doing just a lot of human evals, right? You make a moderation and then you have armies. We basically took over the entire pool of raters that Google search uses for deciding search results are better, one search results are better or not. And that became very, very expensive and very slow. So we trained models that were versions of Bard, right, that were optimized for actually making these judgments, right, deciding whether A was better than B or not. And that turned out to be very, very useful. You can't rely too much on them. What happens is, you can build a model that can mimic a rater accurately for model version X, but the point at which model version X becomes X plus K, right? The correlation between the auto-rater's ratings and the human rater's ratings, they start becoming negative because it's a different set of outputs from a different model, and the auto-rater just doesn't know how to rate them anymore. Yeah. So this is one, it's actually, I think it was a research problem actually, of keeping auto-raters in line with the actual model, but I think it's an invaluable technique that I think is going to be more prevalent in the future, because the old way of evaluating on static data sets, with really strong models, it just doesn't work anymore. You hit 99% really fast, and it's meaningless after that. It's also useful, I think, to have continuous metrics on the training data, right? To say things well, am I getting enough training data from the domains that I really care about? Is the average length of such sentences suddenly become very short? And it's also important to continuously, if you have really complex pipeline, pipelines break, right, without you realizing it, right? Some guy forgets to update the license to some database that you're querying, right? And suddenly you're not getting database from that data anymore, getting data from that database anymore. So a lot, most of, I think, an ML engineer's time actually gets spent in the data part, right? So I don't know if I think just spending more time there and less time on here's a little fancy modeling trick that I read about in a paper somewhere that I can use to most of your time should be spent on the data. Yeah.
In an earlier role at IQT Labs, we did a lot of work with open source data. So that was definitely a place where I would look at the data first. And, in some cases, I was working on a machine translation quality estimation task, and it was Russian into English, and I speak both. So I looked at it, and it was okay, well, these data are not really useful for evaluating that task. And some of these translations are really bad, and, the scores don't really line up. So I think really just the very first step was just looking at a few lines and seeing does the data even make sense? And then at Spectrum, where the data we had was higher quality than open source, as most commercial data sets are, we had a lot of measurements around just the quantities that we had to make sure that we had enough truths and enough across languages. And then for synthetic data, we're looking at a lot of metrics around the diversity of the data, because that is really important. If you just have 10,000 rows of basically very similar stuff, that's not really going to help you. So even though BLUE tends to not be as useful a metric, self-BLUE, which looks at the comparison between all the rows of data, is quite helpful, as well as embedding-based methods that capture the same thing. So yeah, those are some of the metrics we look at.
The way that I like to think about it is kind of a very top-down way, what do users want to actually do with this, and what are they going to care about in terms of the outputs and the quality of the outputs. So for something like named entity recognition at Primer, the audience for that was largely intelligence analysts, and so they cared a lot about the quality of the people and places predictions of the named entity recognition model, and not as much about the miscellaneous category of just various product names and things like that. And so thinking about it from the perspective of your user can really help you sort of focus in on which areas of the model are most important to improve, because otherwise you could just dump infinite time into improving your data set. And actually related to what you were saying, Nina, I have actually managed to make a model worse by giving it more data.